All right, here is perfect problem 1 for Math 243. See, in this first problem, we're given some data and asked to analyze it, basically. The first thing to do is to kind of make a visual representation of it. I said you can make a histogram or a stem and leaf plot. Let's see, maybe I'll make a stem and leaf plot here. That seems a little bit easier. So I have all this data that's ordered. And so what I'm going to do to make a stem and leaf plot is I'm going to take everything that's not the last digit and make those my stems. So my stems range from 7 to 17. You always want your stems to be decreasing. So I'll write those over here. Maybe I'll write all of them. Yeah, looks like it'll fit barely. Something like this. It's important to note that you put stems in there even if you don't have corresponding observations. For example, I don't have 160 anything, but I still put 16 here. So then go through our data. In the 7 stem, I have 70, 72, 72, 75, 75. So 70, 72, 72, 75, 75. In the 8s, I got a 0, 1, 5, 5, 5, 7. 0, 1, 5, 5, 5, 7. See, in the 9s, it looks like I got 2 of them, a 93 and a 95. 10s, I got 2 105s. No 11s. 12s, I got a 125. 14, I got a 145. And 17, I got a 175. So something like this will work for a stem and leaf plot. And then if you ask me to describe the shape of this data, I'd kind of rotate it 90 degrees in my head. And then it would sort of have, let's see, maybe I'll go over here. If I rotated this thing, it would kind of look something like that-ish, which is a right-skewed distribution. My tail points to the right. So I would say appears, maybe data appears to be right-skewed. I think that's good enough for number 1. Yours could be a little bit different if you chose to make a histogram. If you made a histogram, they'll all look a little bit different because people will choose different bin sizes. So that's why I chose to make a stem and leaf plot, so it'll look more like everybody else's. Calculate the mean and median by hand. Alright, kind of tedious. Sorry about this. To do the mean, the symbol we use, maybe I'll write mean. The symbol we use is X bar. And what we do is we add up all the observations, which you can symbolize like this. This means add up all our different observations x's and just divide it by how many observations you have, which is n. Going up here, it says that we have 18 of these movies, I guess is what these are. And if you go and add up all these observations, 70 plus 72 plus 70, maybe I'll write that. Don't worry, I won't write all of them. 70 plus 72 plus ... all the way up to our biggest one, 175. And if you add all those up, probably with the help of a calculator, you get 1710, I believe. And if you divide these two numbers again with the calculator, what you get is 95. All right, median. Usually we'll use a capital M to describe this. What we get is it's the n plus 1 over 2, maybe th, largest observation. So again, we have 18 observations. So 18 plus 1 is 19. Maybe I do this over here. I don't know where to do this. Down here. 18 plus 1 over 2 is equal to 19 over 2, which equals 9.5. Maybe I'll put this in parentheses and then get rid of that equal sign. Yeah, good enough. So what I want is my 9.5 largest observation. And what that means is average your 9th and 10th. And then what we can do is figure out what our 9th and 10th are. Let's see, there's 10 in each row. So this is 9, this is 10. So what we get is the average of 85 and 85, which is just 85. If you want to write it all out, it would look something like that. And so my mean is 95, my median is 85, and then it asks me which of those should I use, mean or median, which one's a better measure for the center. And for that, what you have to do is remember that when you have skewed data, it's better to use your median. When you have roughly symmetric data, it's better to use your mean. The idea is if you're skewed, you're more likely to have outliers or really large observations, and those have a big effect on your mean, but not as big of an effect on your median. So since the median is resistant to large observations or outliers, we say because data is skewed, use the median. Good enough. I guess that's the end of part B. Part C, calculate the variance by hand. All right, this is the one I feel the worst about. This is a lot of busy work. But I think when you go through and do variance a few times, you might find it useful. You might, maybe not. I don't know. You go through and do it by hand a few times, and you start to understand the calculation a little bit better. You start to understand why it is what it is. So the way you calculate variance is you start by listing all your observations, which I'll list here. I'll list my first couple, 70, 72, 72, 75. And there'll be more here. I'll fill these in later. And then my mean, x bar, which we figured out was 95 above. And it's going to be 95 for all of these. And then in this next column, what we do is take the first column and subtract the second column. So what's the difference between 70 and 95? In this case, it would be negative 25. 72 minus 95 would be negative 23. Negative 23, negative 20, and so on. We'll fill all these in. And then our next column, which fortunately is our last column, is this third column squared. So we have to figure out what 25 squared, negative 25 squared is. Turns out it's 625. 23 squared, maybe we'll grab a calculator to do those. I know negative 20 squared is 400. We'll fill all these in. And then what we do to figure out our variance is we add up all of these guys in this column here. So what I'm going to do is pause the video and fill in the rest of these values so you don't have to watch me write everything, but that's kind of the idea. What I did is I plugged in most of these values. Here's the rest of our observations. Our average is always 95. And then what I did is found the difference between these two columns and kind of scribbled those in here. And this should be negative 2. I tried to use lots of 5s here because I knew the mean was 95, so lots of these will be round numbers, which will make them a little bit easier to square. But again, I know this is kind of a pain. So if I go through and I square all these, we're down to the negative 10s here, which square and give you 100. Looks like I have 3 of those. 8 squared is 64. Negative 2 squared is 4. 0, we got a couple more hundreds in here. 30 squared would be 900. 50, 2500, and 80 is 6400. And then what you do to get variance, see the symbol for variance, we usually use s squared. And what it is it's the sum of this last column, xi minus x bar squared, divided by 1 less than the number of observations we have. So this is something you can get out of your calculator, but I know I asked you to calculate this by hand and then check it with your calculator. Anyways, if you add up everything in this column, let's see, how can I denote that? Maybe a sum of all these guys. I think you get, actually I'll have to figure out what you get. Hold on one sec. Finally, I got this right. Add all these up and we get a sum of 13,272. So that goes over here, 13,272. Then what we want to do is divide that by 1 less than 18. So divide that by 17. And if you do that, you get little over 780. Let's see, maybe we'll call it 780.7, I guess, which is our variance. And I guess it doesn't ask you to calculate the standard deviation, so we're good. You can check this with your calculator. Maybe I'll write that down here. I should change color. If you do one variable statistics on all this data, what you'll get is that the standard deviation, which they in the calculator write like this, is 27.94-ish. It's about that 111. And then if you square that number, what you get is our 780.7, which is good. That's a good little check. So that's the end of this problem. A little bit tedious, but hopefully you'll find it a little bit useful. That's the end.